There we go. OKC are the NBA final champions, huh? Oh, wow. Pacer fans are pissed. OKC is probably going crazy. Such a small market to win an NBA finals. Wow, good for them. I'm jealous. That could have been the Blazers. That means the Blazers had a chance. If the small market team... Oh, brutal. Did Halliburton get Finals MVP despite getting injured? Do they still give it to him despite losing, or did they give it to Shea? Hey, Mr. Tim Eduardo, welcome into the stream today. Welcome back, you guys. Woo! Yo! Put on a little jacket here. Shea's officially the MVP. Nice. Well, good for him. That's cool. Congrats to the OKC. Man, that really means Portland had a shot that, like, if some of these larger, more powerful teams kind of choked, Portland had a shot. I don't think that they're any worse than OKC, really. They went on a pretty good run, winning streak at the end there. Woo! I'm feeling this song. You guys liking this song? I am. I like it. Tim, you really are a basketball fan. Tim, if we ever are in the same city, we'll have to catch a game. Wherever they are. That'd be fun. We'll hit the nosebleeds. Abdul, I feels dumb I picked back up where I left off on my Python study and said to try a small question. I kind of went blank for like 10 minutes. What was the question, Abdul? What was the question? Yeah, that happens to me sometimes. That's why I like to make those Python crash course videos that I'm going back through and resolving the Python crash course problems for you guys as like solution videos. I haven't done one in a while, dude. I'm being so procrastinating so bad on my videos. It's hard to do videos and stream because the 2 or 3 hours that I do stream a day, I could have been making videos. It's just difficult, you guys. There's not enough time in the day. But yeah, I went go back through and I solved these and I'm making videos for them. So that's really helped to like solidify those like more lower level, not lower level, but yeah, easier concepts and not forget them. Yo, Python Hubs. What's going on, dude? How you doing, man? Welcome. Welcome in. My hair is all frizzy. It's pretty humid in here. All right, let's go ahead and I got some news, you guys. I've got some news. So for those that are keeping up with the current dev job hunt, I had to complete a take-home assignment over this weekend for a software engineer chemistry position, right? So this past week, like a week ago about, 6 or so days ago, we started polishing up the resume and we started sending out applications. We actually got a bite within the first week. I got a screening. We moved past the screening. I got a take-home assignment. I passed the take-home assignment. And now I have to do a 1 hour maximum live coding interview. Oh my gosh, dude. I'm really, like, as soon as I got the email about an hour or about 30 minutes ago, I was like, my heart sank. I got instantly nervous. Oh my gosh, dude. Like, I'm pretty nervous, you guys. I mean, we've solved like 80 or so LeetCode problems so far, but there's still so much that we need to go over. So many more practice on linked lists and trees we need. There's so many more LeetCode practices, and they could throw anything at us, and I'm just scared, man. I'm just scared. What do you guys think? What should we practice? So this is gonna be our. I mean, we've got a couple of days. I'm not gonna make it. I'm pretty busy this week at work, and I've got a lot of time that I can. I'll have to figure out a time where I can set aside for an interview during business hours. So I will have to see and check my schedule this week. So it'll probably be towards the end of the week. So I do have a little bit of time to kind of prepare a little bit more. But what do you guys think? What kind of problems should we go over to practice for the live coding interview? Oh my gosh, I'm nervous, man. Dude, I'm so nervous. Ugh. It's really hot in here. Come on. Hey, MD, how's it going? Hey, Marty. I'm nervous though because it's a startup, it's like competitive, and I'm with like it's gonna be with one of their devs, right? And so I'm nervous. I'm nervous. Mike, are you going to the World Cup next year? It's gonna be in the USA. Is it in LA or where is it at? Probably in LA, right? Or is it in the Bay Area? Is it in San Jose? Or is that the Olympics? Abdul says, write a function that capitalizes the first and fourth letters of name old underscore McDonald. Quote, McDonald. McDonald note. What? Oh, there's a note. Oh, okay. First and fourth letters of just the word McDonald. Okay. So you could, I think if it just wants the first and fourth index only, or does it want like to do those values, like to do a skip? Like you could do the range function and then get that character, use the ORD function to convert that to its, ASCII character value. Add, I think the value is what, 69, pause, or something to it. Add the value to convert or lessen the value or whatever it is to go from lowercase to uppercase or vice versa. I think it's actually lowercase back down. So you'd have to go down to uppercase and then convert it back to character and then just replace that index. That could do it. Or if it's easy as just calling a range function maybe. You need to practice by giving yourself a time limit, no 2 hour working on a problem. Yeah, that's right, Tim. And it'll be in sites across Mexico and Canada. I think New Jersey will host the World Cup final. Should I take out a loan to go? You like soccer, Tim, as well? You like soccer more or basketball? Yeah, so then that approach would probably work if you just isolate the 0 and the 4 if those indexes are there, present in the string, and then just use ORD to decrement the value, convert back with chr, and then replace the index value. That's how I would do it. Right? That's my first thought. Okay, you guys, here we go. Interview prep. Basketball, then NFL, then soccer. What's your NFL team? You're in Boston, so are you a Patriots guy? You a New England kind of guy? Okay. Let's go here. Come on. Okay. Number 230. Kth smallest elements in a BST, binary search tree. Given the root of a binary search tree and an integer k, return the kth smallest value, one index of all the values of the nodes in the tree. Given the root of a binary tree and an integer k, return the kth smallest value, one indexed of all the values in the nodes in the tree. So given the root, k equals 1. Kth smallest value. What is kth mean? I'm confused on the wording. So we have a root, k equals 3. You're just looking for this value. Follow up, because often we can do an insert and delete operations, and you need to find the kth smallest frequently. Marty, yeah, we're screwed then, Marty. We're done for. It's a chemistry position, software engineer position, so it'll be interesting. We'll find out. Okay, so this one, what is this asking? In an integer k, return the kth smallest value. I'm confused. What is kth smallest? See, this is some of these questions I'm more confused on the wording than the actual quoting of it. Given the root of a binary tree, so we're given the root and just an integer k. Return the kth smallest value, one index of all the values of the nodes in the tree. So the smallest value, the kth smallest value. So is that like the depth, or is this the value that we're looking for? It's saying if k is 2, return the second smallest value in the tree. Okay, because these examples don't really help. They by coincidence give you these, that has these values in there, so it's kind of confusing. Oh, chat. Sorry, you guys. I don't have chat up. My bad. I'm such a goof. My fault, guys. Let's get chat up here. And I'm not streaming on Twitch either. Ah, come on, Mike. I'm struggling today, you guys. It's a lazy Sunday. We want to auto find here. Give me 1 sec. Sorry, guys. You guys are on the stream and haven't liked, please give the stream a like. It really helps to keep YouTube pushing our stream to new people. We're currently building a project right now with a community project. If you want to participate, registration is open in the Discord, which is completely free, down in the description below. So if you're looking to code on a project alongside and pick up some issue requests and do some PRs and stuff, then consider joining the project. Let's go here. Okay. There we go. There we go. I think we're okay now. Okay, so it's saying if k is 2, return the second smallest value in the tree. Okay, interesting. So values that are always to the left. Okay, so we just have to keep traveling left until we reach the leaf and then recurse back k times, right? And then return that value. Because the left of this BST is where all the smaller values are going to be. So if you continually choose left, you'll reach the smallest value in the tree, right? So if we just need to traverse left until we reach a position, we have to go back k times, right? Thanks, Mariddle. I appreciate you. Appreciate you guys. Should we try this one or should we skip? What do you guys think? Is this a try or is this a skip? Let me know. I'll try it if you guys want me to. I'll skip if you want me to. I'm down to try it, but this one looks I don't know. This one looks a little challenging. What do you guys think? Let me know. Let me know what we're doing. Because we're going to set a 30-minute timer and give it 30 minutes. If we don't get it, give it 15 minutes. Okay, we'll give it 15 minutes. Okay, it's a good idea. Hey Douglas, welcome back. Sorry, I was late on the Twitch. My bad, man. Okay. I got TTS on, so no spoilers, you guys, but if you want, we can work through it together. I'm down to work through this one, because I'm not as familiar with BSTs and stuff as I'd say it'd be.
I say 15 minutes as I wouldn't even be able to last a full hour on this question, lol.
Well, that's what she said. That is what she said, sir. Where'd my timer go? Did I start it? I don't like the Apple timer kind of sucks. I'm gonna go to here. I'm just gonna go to the timer online. Let's set this to 15 minutes. Okay, got a timer set up here, 15 minutes. Let's give it a go. I'm down to, let's work through this one together, you guys. I'm down. We're gonna have to learn some stuff for this one, and let's give it a go. All right, starting now. Here we go. Okay, so my idea is that let's just quickly whiteboard for like 2 or 3 minutes. So my idea is that with this BST from these examples, you continually travel left, and if there is no left, you've reached the smallest node, and then you can go right from there or backwards to indicate if there is a node that is greater or the greater node from then. So we need to find the ith smallest node, so the the smallest or the second smallest or the third smallest. So we need to travel down this tree like, should we do a recursive approach? Like, what's our base case? Return, and then we break once we reach the k value. So like, let's say we have this tree here of 3, 1, 2, and 4, right? Okay, so if I'm starting on the root here, right, if I'm starting on the root here, I say like while self.left, right, while I can go left, do go left, okay? My base case once will be while there is no more left, you've reached the smallest value, right? And then we need to, like, we would go left here, right? So we've gone left here. We can't go left anymore, so we've reached the smallest value here. Now, if we want the ith smallest value, the thing is I'm not sure how we would have to deal with going right to check if there are values in between the root of that of that subtree or subtree and the smallest node, right? If there is this 2 that's in between right here, right? So if that's the case, what do you guys think? Okay, so if we travel to 1 and we can't go any further. Okay. So let's define like a helper function, right? And given the root, right? And I feel like we're also going to need to include a count value, right? So if I have a base case here that says like if root dot left, right, is none, then what do we want to return? We want to return a single value, right? That'll to count for this. Potentially, like, do we want to return just a value here of 1 to count basically this node as we go count k's backwards now? So else I would call helper on root dot left, right, meaning that we have one. So then, but we would also want to say so if root dot left is none, return 1. We found the smallest value. No one has any ideas? Chat's quiet. Chat is quiet. No one's got any thoughts? We're already, we only got 10 minutes left here to think this through. So if root dot left is none, return 1. I think my problem in the interview is I'm going to take too much time. Okay, so we continually move left. If I can't go left anymore, I've reached the smallest node. Now, what do I want to return if I've reached the smallest node? I want to return a count value, right? Because I need to backtrack a certain number of times. We're going to call crap, dude. So if root dot left is none, we return 1. Else I will go ahead and call helper root dot left. This is going to return a single value. I'll say if helper root dot left plus helper so if root dot right, we need to call root dot
Ankit says solve in C++.
so if we shoot, if root dot left is none, return 1. If we want to, but how do we handle the right? That's what I don't really understand. Is how do we handle I'll say like count is equal to so I call helper. This returns 1. So I say if I say count is equal to helper root dot left here to get a count here. This returns 1 if we get back down to this node, back to here. Okay. If the root left is, it's going to immediately hit this. But what if k is 1? So I'll say and k is equal to 1. We return root dot value. Else we have another base case if root dot left is none. We return the value if there is no more smallest one and the k is 1, right? If root dot left is none and k is greater than 1, then we're going to recursively call.
Murphy says, hey buddy, what's up?
Hey Murphy, how's it going? How's it going, dude? Okay, so we have 5 minutes left on this one. Oh gosh. We're getting torched here, boys. Anybody have any ideas? The chat is quiet on this one. No spoilers, but anybody have any ideas? Let's go up here, let's check here. Try to utilize a property of a binary search tree. Try in-order traversal. Okay, so in-order traversal, I always forget these things. So let's look up in-order traversal. First visit the lot subtree, then...
Marty says WB the while. Tim says quiet because you need to learn Chan. Tim says no pain, no gain.
In-order traversal. We only have 4 minutes left, boys. We're out of time. Node is 9. Return 9. Traversal. Interesting. Okay, so recursively traverse the left subtree. Visit the root node, recursively traverse the right subtree. So recursively so root dot left is none. We're going to return helper root dot left recursively. Let's see like a simple example.
Nug says doing some binary trees, let's go.
return. So you just return, right? This would be helper dot left, helper right. You just call both. And do we want to sum these together? Say like if, let's return a value. So this is going to return current node that we're on. So this is the current node that we're on though. Right, so we have a current node here that we're visiting. So which is root.value. Say if count count is, I'm going to call it on root left, this returns 1 back here. We're failing here, boys. We are failing. We got 10 seconds. Looks like we're not going to solve this one in time. Dang it. Okay, so let's walk through it. Hello. I am trying to work on, we're not going to look at any code though, right guys? So work on LeetCode 230 by using in order traversal, but I'm getting stuck. I need to detect a reduction in K on backtracking once I find the smallest leaf. Here is my current approach. Hold on, let's say I forgot to ask. Please don't show me code. Let's talk through this. Okay, so in a binary search tree, as an inner traversal, visit nodes in ascending order. So that means that the kth node visited left, root, right. Keep a counter of how many times a node we visited. When that counter equals k, we record the value. Let's clarify. So I had the right, I was thinking about it exactly right, it says. Okay, so when you go left, you're moving towards smaller values. The first leaf you hit on the leftmost side is the smallest value. You want to decrement k every time you visit a node in the order sequence, not just when you hit a leaf. You don't decrement k on backtracking or on reaching a leaf. Oh, so wait, the kth smallest. The first smallest element.
Sentil says, is there any better approach?
Okay, so important, you don't decrement k on backtracking or reaching a leaf. You decrement when you process a node in order. Okay, so let's think. So if it's none, we're just going to return nothing. We're going to call the left. We're going to say k. So this is going to need a count, right? Which is going to equal to k. So, okay, right? So we'll say we're going to reduce count by 1 and say if count equals k, or equals to 0, we return just the root.
Marty says, Mike, are you gonna share the interview?
What do you mean share the interview? I can't stream interview. So we call. So what we call helper on root k.
Marty says, I mean afterwards.
Okay, so if root is none, we're going to return. Right, if root is none, we're going to return. Else we're going to call helper root left, recurse down, check after calling that, and then call right, and then check. Dang it. Starts to unfold. This returns back to here, starts decrementing count each time. This returned. Huh, why? I thought this would work. Oh, so we just need our count to be not passed as a value, but to be... How can I share a mutable object between recursive calls? So we just need a count to be a kind of a global count here, equal to k. No.
Nug says maybe an easy way is to put values in an array in order traversal then return error, K1.
It's count, root is none, helper root per count equals 1 is root dot value. We reduce, we call helper on the right. So then okay, so we need to make this mutable recursive call, right? So you want to have a shared variable that gets decremented as recursion unfolds. But right now it's passed by value, not by reference. How can I share a mutable object over recursive calls? Count equals k. This returns none. Ooh. So I don't know, do I want to say smallest or say result is equal to none and say result equals to value and return call helper on root and then return result. We want to make count accessible. This won't work, I don't think. Count is not associated with the local variable. So we pass k in.
Lokesh says, Michael, have you done any ML projects?
No, not yet. Haven't gotten that far into math yet. Okay, so let's take this. Let's see. I think we're really close here. Not quite kind of outer scope, which is exactly instinct, but there's one important thing here. The Python will treat count and res inside the helper function as a local variable unless you explicitly tell Python to. Scope variables. Oh, in Python you can in the helper function, you can call non-local. I didn't know you could do this. On count and res. Huh. I didn't know you could do this. I didn't know non-local was a thing. Is it similar to global? Yes, great question. Non-local is very similar to global, but more precise and safer. Here's the distinction. Global, the module top level, we want to change a global variable. The enclosing function scope is non-local. We want to change an outer variable in a nested function. If you use global, Python would look for a count or res at the top level of your file. Writing recursive or nested helpers. Okay, cool. I just had to learn about this non-local part, right? We were really close. We were understanding the structure pretty well there. At least we got the idea exactly right. It's just writing recursive problems again. I struggle with the writing recursive. Okay, not terrible, not terrible. That was 230. You're given a 0 integer array nums and integer k. You're allowed to perform operations on numbers where a single operation you can select.
A dig says, what's a whackathon?
It's my community hackathon. We're building a community project together. We're going to build Stalker, a stock portfolio dashboard and trade journal. So if you're wanting to participate, registration is currently open in my Discord within the Whackathon community section, and then I'll add you, if you register, I'll add you to a private thread within that category to access and discuss, features and hop on calls when we're going to work on them and whatnot. You're allowed to perform some operations. For a single operation, you can select two smallest integers from x and y from numbers, remove x and y, and insert at any position in the array. You can only apply the described operations if it contains at least two elements. Return the minimum number of operations needed so that all the elements in the array are greater than or equal to k. Okay. So we have an array here. We can select the two smallest elements, 2 and 1 in this case, perform this operation on them, and then insert at any position in the array.
Says nuts, I think it will take extra space.
Okay, so if we iterate over the array once, how can we, so what's the kind of the more of the, so let's look at this example here. 2 and 1 get selected, which becomes equal to 4, 11, 10, and 3. So they inserted at the beginning of the array. And then 3 and the 4 are selected from there. Okay, so it might be a good idea to sort this array. Start at the front. Get use left and right pointers to select the two smallest values. Perform the operation. And then concatenate a slice, then forward, and the new value together. Right? So, and then do that. But how can we... Our pointers will get thrown off then. So maybe we should just replace values with none. If we replace and fill the array with none, it doesn't want the array, right? It's not asking for the array back, the new fixed array. It's asking for the value back. So maybe what I can do is I can just replace those values, the left pointer values with none, and insert on the right pointer the updated value, and then move the pointers forward. And so the left will always be replaced none. The array size will remain the same. It won't decrease to this size here, right? But we can then keep track and say, okay, if the left and right pointer are greater than return immediately, we don't need to. Okay, that's what I'm going to do. Okay, so let's do this. Let's say n is equal to the length of nums. I'm going to then say for I in range of n less than 1, right? I'm going to apply a j pointer, which is going to be equal to I plus 1. It's going to lead I. I'm going to say, I'm going to perform this operation, right? So let's go temp, or say new value is equal to or I'll just do this, right? We'll say x is equal to nums at index of I, and then we'll say this is index of j, and this is going to be y. We'll say new value is equal to this operation here, right? And then what we're going to do is go,
Karen says, just a quick question.
We'll say first
How
if
do you manage to find time to work on programming post work?
It's called having you want my honest opinion, or you want a sugar-coated opinion? I'll give you that answer first. Do you want my honest opinion about how I find the time, or do you want me to lie to you? The honest answer is kind of sad. This can be taken kind of sad. This might not be what you guys want to hear, because that's what I've had to take, right? So, but we need to make sure that x and y.
Karen says, honest opinion XD.
If x or y, if x is one sec. If x is less than k, or y is less than k, we're going to perform this operation, right? So, in my honest opinion, let me work through this problem real quick, and then I'll answer your question. I want to give you an honest answer and a good answer about how I find the time and stuff. But don't want to lose my train of thought here. Give me 1 sec. Okay, so if they're both greater than, if either one is less than k, we need to perform the operation, right? Because all the values of the array. But we first need to sort the array. So we'll have to go nums.sort. So immediately we're going to hit with a log n time here. So we're going to get slowed down by that at least. That's going to be one of our bottlenecks if that is not the appropriate way to do it. So I'm going to take the new value. I'm going to say if new value is greater than, does that be greater than or equal to? Or equal to? Is greater than or equal to k, then we're going to so actually we don't need to perform this check. If x is smaller, right away we are going to have to do this automatically. So let's just override that and say if x, just immediately do this. Okay, if the new value happens to be greater than k, because this value is what's going to replace the x pointer, or no, the y pointer. I'm sorry, my bad. And then the x pointer is going to become none. So if this new value so let's just insert it. And we can optimize it later. So let's say, so we get the new value. We're going to say nums index of j will become the new value, but also nums.
Nug says, this way and now, yet I was suggesting that to get the idea down, then figure out how to do it without the array up.
Num index of I is equal to none here, right? So, but right away I'll say this. If so in this case, did all of these become smaller? So what was the value that was created? 2? No, 3 was created. And they put that at the end. Ooh. Ah, crap. That puts a damper on my thing.
Nug says, this way and mal, but if we want to be nerds, it won't add asymptotically more space, it's one array, and you can potentially recurse on all elements.
Operation becomes equal to 3. So what I'm going to do then is I'm going to insert the value at this place. Okay. Then on the next pass, if the x value is greater than k, greater than or equal to k, right, we're going to return the count. So this is going to be count out here equal to 0. Oh, sorry, I'm not increasing count. Null. If x ever equals greater than k. K is equal to 20. Okay, so you have to keep doing this. Ah, crap. So then we have to loop over and over and over again. If you get null, it doesn't happen. This will be, so then we have to call a loop here also, right? While true, we're going to do this. This is going to return null. Continue. If this doesn't ever happen, return if so this is going to happen. We say continue here. So greater than or equal to not supported between instances of none type and int. None type, which is getting for here. Oh, because I replaced the value. So if I have to override the nums array every single time, sort on each pass, I want to do that. I don't want to have to sort on each pass on a new array of smaller size. Then it becomes what, n squared log n? No, that sucks. What do you guys think? So, right, it's currently my current approach by going over again. My array isn't shrinking. And if it's none, so then let me say this. If x is none, then we're gonna continue. Right, we're just gonna continue. We're not gonna deal with this. We're gonna immediately override and continue on, increase I forward. Infinite loop. So this kept entering, never got to this point to return x stays none, it continues. This breaks, this continues, enters back in. X So what if I just start, what if I have this inner loop tell me what index I return on? Or, right, if I finish the loop. So let me go here, instead of doing this, let me print out nums. I want to see what happens. Yeah, so it overrides it completely, and then we're left with 33. Which is greater than 20. So it took 4 operations. Oh, curious. This took 2 operations. And this 5. Oh, I'm curious. Is it as simple as this? Or is this just a coincidence? Is it k divided by length of numbers? No way. Yeah, no way. Just a coincidence with the example, I guess. Okay, so interesting, right? It gives us, I'm going to break. Remove this. Yeah, so it started replacing. This became 33. So let me go like this. At the end of this loop, if we say if nums index of -1 is greater than or equal to k, we're going to return count plus equal 1. So this did it and immediately returned. Dang it. Return count. Two operations. That one isn't. Oh, okay, so you have to go all the way to the end. If x is greater than or equal to k, use this test case and run that. Let's go to here. So we went to none. This is bigger. Is it bigger? This is length of 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so this is bigger. So we'll just say if here return count, and we can reduce, get rid of this altogether. $33. Y, which is nums index of j, on the last pass, which is here, oh, because that's not the two minimums. Okay. Gave it a solid attempt here, you guys. We gave it a solid attempt. Let's go get some, maybe so, okay. I am now working on LeetCode 3066. here is my current. Okay, no, we're not gonna look at any code. We're just getting verbal guidance here on how to proceed with maybe some iterate. We'll put the smallest elements into a queue. So reverse order, we top off elements. So let me do this. N is equal to the length of nums. Let's say that we're going to call nums dot sort reverse equals true. Is it reverse or reversed? I'm not sure. Then let's iterate from the back. Let's say while nums index of 0 is greater than this. -1 is greater than or is less than k. We're going to continually get x equals to nums.pop. Y equals to nums.pop. We're going to say we're going to perform this operation, right? Say value is equal to this. Okay, value is equal to this. And then we need to insert this value. I mean, it's gonna be slow, but let's go. Popped it off. Let's go back and insert it potentially. For I in range. Length nums, because this changes, so we don't need this. Length of nums. So we're gonna go from the back though. So we want to go start at -1, go to -n, negative length of numbers, with a skip of -1. And we want to say if nums index of I is less than if nums index I is less than No, so we're going to say if the value that we're evaluating on is greater than, no, is less than num's index of I, we're going to continue. Else, we're going to say nums dot insert. This isn't very efficient, I know, but I just want to see if I can solve it with this way. Insert value so what are my index and element? Okay, index first. So index of I plus 1 and value. Okay. Okay, so now what are we doing? So we're reversing, we're popping off smallest elements, right? We're going to pop off the two elements. Okay, count equals 0. Count is equal 1. Okay, so we're going to, as long as the last integer is less than 0, less than k, which in this case, it should be the smallest one because we're sorting in reversed order. And the length of numbers is greater than 2, meaning we have two values to pop off. We're going to do that. We're going to pop off two values. Sky, stop scratching the door. She's scared of the fireworks. It's okay. It's okay. It's okay. Right? We have a value. We're going to get obtain a value. We're going to loop backwards over our new numbers that we popped with the current length count, right? It gets updated every single time. We insert, and then we're going to break here as well. We don't want to continue going. And so reverse. While nums.
Vitor says nice.
Hey Vitor. While nums -1 is less than k. There isn't a value. So let me override over whatever this and put that forward here, so you can't access that if there isn't length in there. Let me go here and print nums. Popped off. Oh, I is going to be negative. So we have to go I less 1 here. Change to 3. Right? It cooks up 3. It does not insert any more value. me take this out of here, break here, and put after each for loop, we're going to increase the count. 1 right here. Okay, let's see. Here is my current approach. How does it look? The greedy approach. You switch to a more dynamic strategy, but let's analyze what's working, what could go wrong. Sort in reversed order, so num's -1 gives you the smallest element. Smart. Popping the 2 smallest elements, combining them with the correct formula, reinserting the new value in the list at a sorted position. This shows clear understanding the greedy strategy and simulating a sorted structure manually. You're replicating a priority queue heap does. Issues to watch out for. The insertion logic could fail. This may not insert the value if it's smaller than everything.
Myrtle says count should be indented once.
Yeah, counts has to go here, right? No, let's go here.
Vitor says replace for and while with append and sort.
You may not answer that. Even though it's, that's what it's recommending me here as well, is append and sort. I was trying to avoid resorting on every call. And you would stop without checking on everything.
Nug says, do you know a data structure that maintains sorted order across operations? Myrtle says, I think count should have been indented only once cause our end count is increasing when it's inserting the value and not when it's continuing.
Yeah, it counts on insertion. Okay, so then let's say like this. Let's just go range of n, right? If the value is less than num's index of I, we're going to continue. Else we're going to call
Myrtle says, oh sorry, my bad, I thought it was for something else.
All good, dude. If the value is less than the number, right? If we come up to a number and it's less than, we're going to pass over it because we need to have less values be on the other side. But we're in reversed order, so we have higher values here. So if it's less than the value, we need to go over it and potentially insert it there. Okay, right? And so return count here. Right? If you go through this loop, continue up to end. Will we potentially miss one at the very end? Let's find out. Is not defined. Do you mean any? Let's see. List. This is becoming a list. Num index of -1. What? Less than not supported between types of lists and int. I'm indexing into a list. What? There is an error on my while condition. If nums1 doesn't exist, like it's an empty list. Okay, so we'll say if nums. Wasn't it? Oh, because it's reducing down every single time. So while nums and length list, we need to first make sure there are nums in there. Ah. Come on. Ah, we're back here. Lots of bugs. Okay, we got that one. Off by 1 there, off by 1. So we have values left over. So this has the operation that it can do, but it's not doing it. This goes down to 0. Huh. I really want to break on the count. We don't need to keep going. Just off by 1. This is reducing it. Oh, I'm inserting in the wrong order. Okay, so I need to insert, because I have larger numbers out front, my value could be larger. So in this test case, I'm inserting this 15 ahead of the 9. If the value is less than numbers index I, 15 is not less than. So if it's greater than, no, if the value is greater than, if the value is less than, we're going to continue. We're going to also insert at I. Right, because we need to insert at that position. So now the 15 is there. Good. And the 299 is here. Good. So now this isn't this is popping off the values, the last two. What do you guys think? This makes it empty. Oh, so this isn't happening because it's empty, right? So we'll say if not nums and value greater than k, greater than or equal to k, let's go count plus equal 1 here. Return count. Come on. Come on. Ah. Dang it. Printed nums. Perform an insertion. I'm so curious to what the answer is. I'm not gonna cheat it. We're gonna get there. Always want to increase count, then break after inserting, and then we say else here. Right, we need to add the value if it never was inserted. Right, you have to go nums append the value. increase the count no matter what. One too many. Place in line the value. So what if we instead like have like a flag? So like inserted equals to false. You set inserted equal to true. Like if not inserted, then you're going to append the value, but always increase the count. Five, three. So then if numbers breaks, you'll always get a count. I don't think we need this anymore. I think that'll do it. Dang it. So if you have numbers, you don't even need this then, because we don't want it to enter the while loop if there is no numbers. Because you either have a length of 2 already. Does that change anything?
Anand says, hey man, what's up?
Okay, here we go. Okay, I think that did it. Hey, Anand, how's it going, man? I think we solved it here. Oh, no. Output limit exceeded. It's just that print statement.
Anand says, long time no see.
Hey, dude. Time limit exceeded. Oh. We're really close, I think. A time limit. Here. Foreign numbers and zeros. Case. Oh.
Hinami Spy says, skewiches. Hinami Spy says, did you get an interview?
Yeah, I have a coding interview at round number 3. Okay.
Konami Spy says, can you share where or not?
It's just a startup. I've never heard of them before outside of the interview process. So it's not like any name that would be familiar. It's kind of like a niche science software company that
Konami Spy says, did they ask mediums or easies?
I haven't done a LeetCode with them yet. I did a screening with the recruiter, and then I did a take-home problem with like a 2 hours time limit, which wasn't too challenging, but it was a little bit challenging. It did utilize like I did have to utilize a few like algorithm techniques, like such as a two-pointer approach. There's a couple of ways I could have solved the take-home problem. It had I'll share more detail on the take-home problem if I get the job, but it had like some um, you just had to like access a file, get some data out of it, and parse the data. It's a lot pretty similar to what we did with our SpectroSim. So I'm really glad that we did that, that work on SpectroSim. So it really goes to show you guys that those real world projects actually did come up and to benefit me for the take home, because that web parsing that I had to do for the PubChem API request response that I got uh, was very similar to the type of parsing that I had to do. Um,
Konami Spy says, just use Cooling.
I had right just to that I had done in my SpectroSim. So what I did was I had to get some information out of it, and then I had to analyze the information for a specific data point that was needed and then like I had to it was a huge file with data in it, and I had to find a specific point that it wanted, and then that correlated to a specific like indication of this kind of data. Without getting too much in it, it's kind of hard to explain without actually telling you guys what it was. But then and then you had to once you got the specific data points out, you just had to plot it with a plot tool in Python. And then when I just wrote up a quick, so I did come across a point in when I was accessing those data points within the file itself, and I actually when I already extracted out the information, not the information I needed, but kind of narrowed down to a certain chunk. I had to actually I came to a crossroads where I needed to implement an algorithm to actually go through this data efficiently. So I actually did implement a two-pointer algorithm to go over and detect a certain change over across of adjacent values, and then I was able to return and break out of the loop or not break out, return and break out of the search easier once that change was found, rather than having to sort or do other
Konami
types of
Spy
things.
says, is this a monotonic stack?
Monotone. I'm not sure what you mean. Anyways, but yeah, so it was a pretty good, cool. It was a cool problem. It was once I felt really nice when I got the data points I was looking for. That gave me an example. The first, I think, like, um, you know, 10 or so data points that I was looking for out of like, I think it was over 300 specific ones. So I had to, and then obviously plotting those 300 specific points. Um, and so it was really cool. But there was also another part of it where once you access those data points, you kind of had to filter out the data points with a different technique as well. So I had to do that two-pointer approach to detect the change in adjacent values across this data field. But I also had to use a modulo to detect alternating um, even or odd um, like data counts, basically, because every other data point represented a different point, like a an alternating field, like a different bucket that it went into. So you kind of were like scraping through the data like this, like using the modulo operator, like pushing one off to the left, pushing the other off to the right, gathering them into buckets, and then plotting those two buckets on a graph together. And so that's what I was able to do and make it. And then I wrote a little README describing my algorithm approach, and why I decided to go O of N, and what method I used, the two-pointer. And yeah, and I got the email saying I'm moving on to the next part, and so I have to do a live coding thing. Oh my gosh, I'm really not looking forward to it. I'm really nervous, you guys. Not gonna lie, I'm not gonna lie to you guys. I'm pretty nervous. Monotonic stack. Monotonic stack. Oh, gotcha. Yeah. Okay, so then we're getting a time limit exceeded because of this insertion. So then let's just do this. Let's just remove this altogether. And let's just go nums.append value, nums.sort, reverse true, right? TLE. Oh. Yeah, so they want you to use the. Okay, so we're gonna have to do. So I've never used it before. I've heard about that. We're gonna have to use the import. Is it min heap? No, heap q. Right, and then we're going to call heap q dot heapify on nums, right? Then you call thank you so much for the follow on Twitch. Heap q dot heap pop on nums. Then we're going to do this again for the y value. We're going to, instead of doing this, we're going to heap q dot heap push, which will push the value onto the heap. And then increase the count. Two arguments. Heap push has two arguments. Oh, we have to provide the numbers list as well with the value we want to put onto there. Interesting. So heap Q. I've never done heap Q. Let's look up heap Q. The heap queue algorithm in Python. This module provides implementation of the heap queue algorithm known as the priority queue algorithm. We've talked about these in DSA and Python, right, in our book. Heaps are binary trees in which every parent node has a value less than or equal to its children. So the other smallest value is the root node, and it cascades downward from there. So you pop off, and then it rotates. This implementation used for counting all k elements. The API below the text from heap.sort maintains a heap invariant. Heap pushes the item, pops, heap, push, pop. Heap merge. Interesting. Okay, so then we say okay, so then we just have to, I think, right, because we're changing this to a heap, we're no longer doing this reverse sorting, so this is what's wrong here. If we put a 0 here, or the 0 element in this heap list of nums is going to be the smallest value. There we go. I think that solves it. Oh, here we go. Pretty inefficient though. Oh, so we don't even need to do these min operations, right? Because x is always going to be the minimum of y, of x and y, because it's in the heap queue. So we can just apply x, y here. That'll submit. So now we don't have to do those min operations. That'll save us some speed. Okay, that brings us all the way up to here. So then you would save it even further by placing it inside of here rather than doing it in there. So you just automatically do it here. About the same. Interesting. So then this one is you return n minus the current length of numbers instead of keeping a count. The new total, the original minus the new length. Basically how many operations it took to lower it down. Okay, yeah. So if I do that instead of keeping the count here, does that reduce it even further? So return n minus the length of numbers, right? When n is equal to the length of numbers at the very beginning. Trying to get there. A little bit better. So not all the way over here. So this has while length, while is just less than k. So you don't even need this. For all the examples, I guess. Okay, because I'm doing a length call on numbers every single time. So if I did remove this, it probably would save me some speed, and I'd probably get put up to here again. No, I'm back to here. So it's just I guess it's just a difference of 2.py. Yeah. Okay. Whatever. Cool. Oh, sorry. Did I get a raid in here or something? Oh, my bad. Hold on. I'm switching my tech stack to React, Express, Gunnercore, Redis, Elasticsearch, Tailwind. Nice, dude. Hey, Preston. How you doing, man? Sorry, I missed your chats. Hey, Preston. Hey, Atito. I appreciate you guys joining me here. Welcome, welcome, welcome. All right, so we solved that one. So we had to implement a heap queue. So the heap queue is I didn't know this. A heap queue is just um, a priority queue, which in a tree form, right? Which is just the smallest numbers first, with their children being larger numbers or equal a value, right? Cool. You learn something every day. We have solved 88 LeetCode problems. Wow. I'll give you 1 second. We'll talk about it after. All right. Thank you for the follow on Twitch, Tito. Appreciate that, my guy. You're the guy, dude. Okay. We got Preston the God over here on Twitch and YouTube. Thanks for the double dip. Okay. Cool. So that's 88 problems solved on LeetCode. Okay, if we get an easy one, we'll do it. If not, I'm not gonna. I'm done for today. Come on, it's just giving me mediums. Okay, here we go. Actually, we got it easy. Remove trailing zeros from a string. Given a positive integer represented as a string, return the number without any trailing zeros. What? That's so easy. Okay. While num's index of -1 does not equal to 0, we're going to call nums dot pop, and then return stir num. So num is a string. Oh, it already is a string. So we're just gonna continually pop off the end of the string while if there's zeros, and then return number. If I get this wrong, I'm scared. Oh, you're right. It's a string. It's not a pop method. Haha, you're right. Never mind. Okay, so we need to. So to remove a zero off of a string, we just have to replace it with a blank. Oh, interesting. So you have to do like a pop mechanism on a string now. I got to think about this a little bit. Okay, so if we want to do like a pop mechanism on a string, well, we could convert to num, or we could convert to a list and then pop, and then, right? So we could, what is it? Is it, can you just call list on, can you just call list on a string? Can you just call lists on a string? I know you can value for value within, you can go like this, right? You can just say, we'll say L is equal to val for val in um, num, right? And then can we just go while L index of -1 is equal to quote 0, we're going to, um, or we could just keep a count of how many zeros are there and slice off the back, right? That'd be another approach rather than, so I might do that actually. Yeah, so let's do this. Let's say count is equal to 0 for I in range. We need an n here. Length of nums for I in range of, let's say we want to go backwards. So negative 1 to negative n, -1. We want to, if I, or if num index of I is equal to a 0, then we're going to increase the count by 1. Else we'll just else we're going to break, right? Because we don't, once we hit a value that's not a 0, we don't need to count anymore. So then we're going to say return num. We will slice. How do you slice off the back? Can we just slice off the negative count? I'll say string negative, let's say like 5. That might just give us the last 5. Therefore, extract a substring starting from the beginning of the character going up to 2, but not including the last 5 characters. Okay. So go, but not including the count. So if you have, so let me just quickly go here and say print rather than, let me see what I get here before we submit. Oh, no. No, no. Because there is no zeros there. Oh, wait, hold on. No zeros here, but there is zeros here. So we get standard output of 2. Output null. I got 2, should be expected. Perfect. So then we will turn the slice here. Oh, like, that's back again. Okay, so okay, so we'll say return this if count, else none. All right, cool. All right, so there is one that's faster. That's way faster. Maybe just pop. Oop, what happened here? What happened here? Where did my thing go? Heck? The heck? Um, what the heck? Oh, there we go. I think, yeah, strip would work too, right? Could we just return num dot strip? I always forget about strip. It's kind of like one of those functions that I always forget about. Would that work? Yeah. I always forget about strip. Boom. So if you can use a strip method in Python, or you can go ahead and do it manually if you want to. I always forget about strip. Strip that down for me, baby. Yeah, so you could also convert it to a list and pop off values and then join them together, right? That would also work. But this one doesn't create any more memory, right? This iterates on the current nums too, rather than slicing. So this one is way better. What is behind the strip method? Um, because this one uses 18 memory. So let me go here. I'm gonna go here to my code here. I'm gonna go to let's go to the GPT. I'm gonna go. I solved. What is this? 2710. LeetCode 2710. Pretty easily. Um, one using the strip method on num, and one iterating over the back of num and slicing off the negative count of zeros. What under the hood makes the strip method so much faster? You asked an excellent question. What under makes the R strip method so much faster manually iterating over the slicing? We should probably use R strip in this case. We don't want to strip off leading zeros, right? So R strip is probably the better way to do it, more the safer way to do it. Right, so you're not taking off leading zeros, even though leading zeros technically don't matter. It is a string, so. Okay, it's written in optimized C, runs in a tight loop and optimized function object allocation. That's why it's significantly faster. Under the hood, rstrip is fast. It's C implemented, not Python. Python's built in strings like strip, split, join, etc. are implemented in C. They loop over the characters happen at a native speed. Memory allocations are minimized, not interpreted overhead per interpretation. Okay, so rather than having to do this like what I did with a Python loop, the methods that come with Python, like we know, are written in C, and so it's just fast. The default methods are faster than recreating them with Python. Every part that runs through the Python interpreter involves reversing a string, iterating through objects, counting, slicing. No intermediate objects. R# doesn't allocate anything during the scan. It just finds the slice index and returns a new view / string at the end. The C implementation of R# is highly optimized for removing tailing integers, something like this. While the end is greater than the start, and chars to strip include. This is way more efficient than Python's interpreted logic. S end -1. Use rstrip whenever it's more possible. Nice. All right, gentlemen. This was a good stream today. I need to, let's see here. You guys are not in the Whackathon project. Consider joining if you want to build a project with me. We're building a live project here. So go ahead, and if you guys are interested in this, you guys can go ahead and access it and build alongside me here. You can register in the Discord link down below for free. I have a Discord link down below with an entire roadmap of my learning journey so far, teaching myself how to code for the past year. I have a degree in human biology and a minor in chemistry. We actually I have a job interview this week. I passed the take-home portion and the recruiter screening, so I have an actual interview with a member of the dev team for a software engineer chemistry position, so that's really exciting. I'm pretty nervous for that. We have you can access this in the Discord where you can register via a Google form. I'll add you to the private just subsection in that Discord category for where this project is being discussed and where we're implementing features and whatnot. So it's really, really awesome. Did I add him as a contributor? I didn't mean to do that. Or is it just automatic? Huh, why isn't anybody else on here even though they've also committed? Interesting. So I opened up some issues, you guys. I opened up some issues for writing some objects. So we're going to, I'll probably start writing these issues on stream over this week. Well, I'm studying for that interview, so I'm doing a lot of LeetCode problems and studying algorithms and stuff to practice. But I want to keep our projects going, so I'll try to find some time on stream to write some of these classes, such as we're making a stalker app, which is basically like a trade journal and a portfolio dashboard. So you're able to link up your accounts or across all your different brokerages manually, and then you're also able to log trades and whatnot. So it'll be kind of cool. I think more like a manual kind of approach. I want to keep it manual so you have some incentive to not over trade and stuff like that. But yeah, it'll be kind of a cool project so far. So we just have a couple of tasks to work on, creating some objects and classes to get the structure going. So you guys can register and join the project in the description below in the Discord. So let me go to the Google form real quick and add in some people that registered. Okay, here we go. Responses. All right, we got some more registers here. So let's go add them into here. Discussion here. We want to go into this guy. Add permissions. Add members. Okay, so let's see who is in here that we need to add. AKM. AAD. ITU. Uh, SG Code. Already added him. I think I added Douglas already. Yeah. OPX. Already added. MRI. Already added. Daunting pair. Oh, AJ wants in. We'll add AJ. I think that's it. We have how many here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I think I'm missing somebody. Um, done. Cam. Done. Okay, I think that's everybody. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yes. All right. Cool. All right, you guys. I will see you guys tomorrow. Make sure you guys chat with me in the Discord if you guys are wanting more information about the project. We'll get it going here. It's just gonna be pretty simple. It's a lot of the projects I've built in the past using just React, Tailwind, and Python and Fast API. Nothing too crazy. We don't need any like crazy package management or anything like that. It's really just more of a simple learning project. And if we want to expand it out later on to be more, universally industry standard or whatever, then we can. But just for the time being, this is just kind of a whackathon project or hackathon project that we're going to use to just learn and get some more project management experience and working with everybody in GitHub experience and everything like that. So thank you guys so much for being here. I will like to preface though that 99% of the code written for the Whackathon should be written by you. So yes, I do prompt the AI myself. I do prompt the AI to learn and to grow as a programmer and learn more knowledge and stuff and whatnot. But I don't ever prompt the AI to generate me code and use that code because that just defeats the whole purpose of this stream and whatnot. And if I ever am doing that, then why would I? There's no point in really learning this stuff. So I will preface that if you guys are writing for the Whackathon project, please 99% of it needs to be hand typed out by you. Now I'm not doing this to be like strict or to be mean or anything. I'm just doing this because at the end of the day, it will help you and me, to better understand and learn. Also, if the AI is just generating and we got pull requests for like 10 different files at once over across of like 1,000 lines of code, then the project is going to expand rapidly and kind of get out of control. Especially if it's all AI generated across different people's AI, it's going to get really really messy really really fast. And this isn't a vibe coding project. This is an actual learning project. We don't vibe code on the channel. I don't really do that. I've never done that. I write all my own code and yes, and I will preface, yes, I do use the AI to learn, right? That is my main learning resource besides textbooks is, prompting the AI to teach me more about topics that I'm unfamiliar on and to gain further knowledge about those, just as you would go to your TA or professor with those same questions, right? Your TA or professor would never outright just give you answers unless they were trying to teach you something and have you learn from those answers. And that's the same exact approach that I'm keeping and using with this. So, use the 1% of it. AI is fine to learn and grow for certain topics about how to use React, how to do like command line stuff, install packages and whatnot. That's all cool, but at the end of the day, write it out yourself, guys, and it'll be cool, and then everybody can follow along too, because we have a lot of people that are very new to programming here, just as I was and still am. I started just a little under or over a year ago. So thank you guys so much for hanging out with me here. I will see you guys tomorrow. It was a lot of fun building or solving these LeetCode problems today. We're going to keep going with the project. I still need to keep going with math and calculus, but I'm just procrastinating that pretty bad. But anyways, I'll see you guys then. Thanks so much for being here and hanging out. I'll see you guys in the next one. Bye. Have a good one.